The same problem.
Yeah.
If you want to use
Get this session started.
need a tool set.
Hello, my name is Ryan Arnold. I'm the Toolchain Engineering Manager for the Renato Toolchain Working Group. Welcome to LCU14-205. I believe the title is Multi-Arch Compiler Driver. So this discussion will be facilitated by Maxim Kuvyrkov and Renato Golin. You can find the slide deck header on Zarista, but this is more of a discussion rather than a presentation. So we'll use the Eatherpad on this one. So if you have comments or questions that aren't being addressed, put them on the Eatherpad and I'll try to interject. We'll have the time at the end. Well, we're just going to have a discussion throughout the whole thing. So I guess I'll just turn the mic over to Maxim to get this going.
These work.
These are recording.
So my name is Maxim Kuvyrkov. I'm tech lead for the Toolchain group. And today I will be hosting a discussion together with Renato Golin, our LLVM team lead, on the unified compiler driver or multi-arc compiler driver. And this is a possible project that Renato might do if there is support from the members on solving several things. One of the things that in the ARM land is different from many other ports is that ARM 32-bit, ARC32, and ARC64 do not share a GCC backend. They are completely different and separate backends. So you cannot use the usual M32 and -M64 options like on the other targets. Then there is this possibility of creating a new driver on top of existing GC compiler. So there is GCC for ARC64 and for ARC32, which are different compilers. Maybe we can put something on top of them so that to the outside application, they will look like a single compiler. A unified compiler driver in this case will be the entry point and would use GC drivers as backends. If we can do this with two GC compilers, then maybe we can also add other compilers in the mix, possibly LLVM. So this is another point that we want to consider.
I have one question.
Someone will need to help me with the mic.
I can do that.
Yes.
So I have one question. Isn't ARC32 going to be deprecated? Or rather, more in terms of like it's not deprecated per se, but basically it's old and should never be used ever again.
So ARM v8R is ARC32 only.
Right.
Okay. So.
But then, if that's the case, then you have another compiler for that. That's R is a separate, from Linero. R is not really. What's R for, anyways?
Real time. So that's generally automotive type stuff.
But real time I don't know.
No, ARC32 is not deprecated. If you look at the V8 documentation, there are new instructions in ARC32.
Right.
Let's look at the x86 example.
Yeah.
Is 32-bit deprecated?
It's
how many years? I've lost how many years x86 has been going on.
The whole point of that is that, let's move forward. Let's move forward. Let's not look back. So having a wrapper like this, I think, is a waste of resources, and it's not pushing the whole Linero ARM forward. It's pushing the Linero ARM, to the side.
Do you have an alternative?
Yes.
Excellent. Thank you.
I have an alternative.
Go on.
ILP32. But except for the ARM stuff, the R, and the R for Linero, it might not necessarily be useful. I don't know the exact in terms of how much automotive actually will be running it with ARMv8 and Linux on the R.
You probably will.
So that's the question.
So yes, R is 32-bit only.
Right,
Yeah,
that's what I'm saying
but-
is it useful to go forward with ARMS32 for the A platform at all? I think not.
So before we go into
And
the
I think
discussion
it's
of
actually,
something being obsolete, before we go into the discussions of something being obsolete, let's look at today's applications and what people want to use such a project for. So,
I want to say, sorry.
We need more
Here
microphones.
again. So I was going to say, I think I agree with Andrew that the wrapper as you propose it is a bad idea, right? I have a constructive alternative, however, rather than not doing anything, which would be to actually finish off the effort that started in GCC a while ago to have multiple retargetable backends so you can select backend on the command line.
Like LLVM. Oh,
So-
sorry.
yes.
that's a better alternative. Yes, I totally agree.
Before we go on with that, just to clarify, wrapper or driver is one of the possible solutions to the problems that we have. So we want to gather all the use cases that there are, and that this will be the first part of the session, and the second part of the session will be possible solutions like finishing off the hookization and modularization projects in GCC, using a Python script, using a shell script, using a wrapper. So first part of the session, gather the use cases. Second part of the session, figure out how to cater to those use cases.
So you're going to go forward and explicate exactly what problem you're trying to solve.
Yes.
Okay.
Okay, I can tell. So this requirement was set by me at the TSC of Linao, because in ST we are using a GCC compiler for our ARM-based SOC, and we have to deploy a compiler for bare toolsets, in bare toolsets, and compiler in Linux toolsets. So if you consider bare toolset, it's a toolset you use to not to compile Linux processes, Linux application, but to compile bare machine code for security people, in security team, people writing the bootloader and so on. So we end up deploying 4 different compilers. Two V7 toolsets, bare and Linux, and 2 V8 toolsets, bare and Linux.
Right.
This is one problem we have.
So actually, Octeon already
have
has a similar issue. We deploy 2, well, 3, if you call Big Indian or Little Indian also. So we have a similar issue, but we've actually have it's a manageable situation, and people get used to the extra compiler. And that's what I'm saying. It's a manageable situation from a point, but there's it's a good goal to do the refactoring part. Doing this driver, I think, is useless.
Okay, I will come back to that, but we are on the use case.
Yes, the use case is reasonable, but I'm saying is having a higher level driver to do
Lower
it.
the driver. It's just the title of the session.
Right.
We put the discussion in the wrong order. We should
Yeah.
start from the requirement and then see the possible solution. Then you have the problem of we have the problem of deploying that at customer level, not only in our engineering teams. You have the problem of documenting that, training the people. So this is traditional software engineering problems. Okay, but it's a deployment problem compared to Intel.
Where there's other companies that have had this problem and have solved it already. So Monta Vista, for example, has a similar issue. You know how many tool chains they support? Probably 5, 6, and it's deployed between and it's deployed to each of those targets.
Okay.
Separately. So it's not a new problem.
It's not a new problem.
More than that, it's also, if it's a solvable problem in a refactoring way, instead of the whole driver, I think that's a better solution.
Yes,
But
we all agree
I
with that.
agree with you, because I'm not in favor of this third driver.
Nobody likes the driver.
Okay, I'm in favor
Except
of another
Maxim.
solution. So the second issue that we have is with open embedding, with Yocto. Because Yocto makes the assumption that you have one cross-compiler. So if you have to build with Yocto a distribution where you have both 64-bit, 32-bit legacy, and ILP 32-bit application, you have a problem, because
it's a solvable problem in Yocto world then, instead of it can be a solvable problem in Yocto rather than a solvable
yeah, but
here.
what I'm saying is that if we have, as on the other target, like on Intel, a single compiler, it just solves the issue of open embedding. Okay?
But it's also a
It not solve all the issue.
besides just solve the problem here.
Okay.
It sounds like.
So I have sympathy with your use cases. So my experience with customer support over time in ARM is there is a lot of confusion, and you get people coming up to you and saying, these are my command line options, I'm producing 64-bit code with these command line options. So you then have to educate them that they're using an ARM, NUMI, ABI, GCC, and you go, that's not going to give you 64-bit code. No matter what command line options you give to it, you need to use ARM64, you need to build a different way. So I have sympathy that this is actually, at the very least, there's a major education problem. I don't know what happened. I see we've got Richard Henderson here, so I'm going to drag him into the conversation. But what's the experience on, because you're GCC x86-64, x86 backend maintainer, I believe. What's the experience in x86, so I'm dropping you in it here, on that education process of getting people to understand whether they're doing code gen for 64-bit or 32-bit or using the compiler correctly? Was it confusing, or did people just pick it up?
I'm not aware of any confusion. Of course, the fact that it is just an M32, M64 switch on x86 makes it slightly easier.
But that's what we're trying to achieve, is to have one flag that makes everything beautiful.
Sure, and
it doesn't
actually when I was talking with
it doesn't work.
Ravana the other day, actually the ability to split out Thumb1 into its own compiler would enormously clean up the ARM32 backend as well. So I'm actually all in favor of having a sort of unified driver that can decide based on command line switches which backend it wants to load and run.
Which is essentially solving the problem in the compiler to make it switchable between multiple backends and complete the transition that we've started.
Yeah.
Yeah, I mean, we sort of started that with the target M structure a couple of years ago, and honestly, we haven't driven that through to completion. So finishing that is sort of, it's not like it's, we thought we were going to push it all the way through once upon a time, and we didn't ever really quite get there. So finishing the job would be fantastic, I think.
Go on.
Go ahead. So in ST we have made a proof of concept with regard to a merge compiler for both Arch32 and Arch64. We can share that with the maintainer and of Free Software Foundation and Linaro experts. The idea is the following. If you try to do a merge compiler with all the ARM targets, you end up with lots of difficulty because you have to handle the Thumb1 case, the ARM case, ARM32 case, and the ARM64 case. It's too many things for a single compiler, and it creates problem if you want to have common patterns and use iterators for either generating the thumb code or the ARM32 code or the ARM64-bit code. So the idea is to, instead of trying to merge everything, is to make a single compiler only for and articulate the merge at the V8 architecture, making a merge compiler only for ARch64, thumb2, and ARch32. So this is the idea that we have pursued in ST, and we have a workable compiler for a subset of the instruction set.
You add the 32-bit. Did you add the 32-bit instruction set into the ARch64 port, or?
Yes. Yes. So thumb2, ARM32, and ARM64. And we can share this experiment with whoever wants to look at it.
I believe Matthias had a comment.
Well, I don't like this driver approach, and GCC upstream did remove this kind of support several years ago to be able to call other backends, say cross-compilers and other GCC versions, because it caused too many issues, apparently. And the second issue is, I think that ARM32 at least doesn't have proper multi-lib default support. So the thing which is available on MIPS on x86 and Spark is not available on ARM. And apparently there's no interest in getting this implemented. I'm not sure if that would solve the ARM64 problems, because well, then you would have to need to include the ARM32 and the ARM64 backends. But it would be a first step to reduce the number of compilers needed for the different ARM32 variants.
I think my biggest problem with the driver would be that it would create something that is meant to be temporary, right? And then you're gonna, instead of solving, like reducing the number of drivers that you can use, you're gonna increase, because people will be able to use the ARC64 and the ARMv7 and the unified driver. And then all the build systems will be adapted. Some of the build systems will be adapted to these things, others won't, and they will do their own adaptations. And then we kill this once GCC can have multiple backends, but you still have the unified driver, so that will linger forever, and then it will be a weird thing that somebody did in the past. So my opinion is that if this is a stopgap for helping us with these problems that you have with the multiple toolchains, etc., that may be a localized thing that we do for the members when they have a problem, and we solve temporarily the problem until the GCC driver can actually cope with multiple backends. Then we say, look, let's then try to make this temporary driver very similar to what a GCC driver with multiple backends would look like, and then you can do the migration without problems. But if we just like write a Python script to fiddle with the things, that it will make things worse.
So,
well, there are two approaches how to call some multi-libbed compiler. The one option is to call the compiler name with -m something, and the other option is to build a fake cross compiler which just uses, for example, the triplet name and sets the correct options. I'm not sure if that's a solution which would benefit you as well. So
that's more or less what LLVM does.
Yeah, so I was just kind of stick my oar in. So it's kind of a bit more of a distro perspective from people who actually have to build stuff with your compilers. Ultimately, I don't care how the actual compilers are arranged, but it's very important that this is done properly orthogonally. And so the x86 people got this wrong 10 years ago, and trying to copy them with -m32 is the wrong way of doing this.
Right.
Everything should be triplet blast, triplet GCC, is how you call your compiler, for the ABI you're targeting, and then everything gets selected. And if you install multiple compilers to do that, or one compiler with several backends, I guess I don't really care. It's easier if it's one compiler per backend, I think is the right way to arrange this. So I'm not quite sure what your customer's problem is with installing more than one compiler. Is it just that you're not building compilers that are co-installable?
Sorry?
But installing ARch64, Linux GNU, and Linux ARMHF, GNU. So you just install two compilers, and one for ILP32 if you want to target ILP32. So install a compiler for each thing you want to target. Very simple. It's easy to install, it's easy to call, it's easy to make dependencies that work. Everything just works. As soon as you go, oh, for this architecture, we're going to put these three random things together, and then now you have to know that on this architecture there's a special rune for...
So it's actually a limitation in Yocto that's causing the problem.
You're right. So if Yocto can't cope with the idea of more than one compiler, we should fix that.
Yeah,
not fix it differently for each architecture. So the ARM situation will be different from x86, different from MIPS, different from Spark, different from PowerPC. I think that's the wrong way to go, just because Yocto is a bit dim.
So hi, Ian Webster, LLVM Linux. We've been working with the Yocto project for a little while. We actually want to get our kernel patches as far as building the kernel with the LLVM working in Yocto. One of the things that we've had troubles with, of course, is using Clang as part of the Yocto build. Kamaraj is actually working, albeit in his spare time, to ultimately support more than one compiler in Yocto, such that you can choose on a per recipe basis which compiler gets used, GCC or Clang. So this is a temporary limitation.
Which command gets used?
Pardon me?
Which command gets used? Is the problem installing the compilers, or which command you issue to get something compiled?
Correct. Second.
Right.
Which compiler is going to be used for a particular recipe?
Okay.
So he's adding, the idea is to add dependencies and multi
So you should just
compiler
always
support.
call triplet GCC everywhere for what you're targeting, and then it's...
Well, he's still working on that mechanism. The idea is that you can ultimately choose which compiler to use, because it's not an either or. Right now, not everything, as the work that's being done in Debian, of course, we already know that not everything will compile with Clang yet. And so as a result, the idea is that even if somebody wanted to use Clang exclusively for Yocto, that's not yet possible. And so being able to support more than one is required at this juncture.
So Clang also works with triple-Clang.
It does. But the idea ultimately, you choose which one you wanted to use. Certainly in the kernel, we use the triple. We use the triple the same way. We just essentially pass it in as the target.
And so the work you just described is being completed in Linaro?
No, it's being done by Kamaraj. He actually currently works for Comcast, but it's something he's doing as part of his open embedded work. So it's not actually part of directly what he works on.
So it means that Yocto would be able to support any number of compilers?
Right now, he's trying to enable a second one. So I mean, as far as this is concerned, it's not probably letting the cat out of the bag. The point is ultimately, the plan is to support in open embedded. He's trying to enable the support of more than one compiler. Right now, two, but he's not. I don't think, considering his past, he's not going to preclude anything more than two, I imagine.
So Linaro has a problem as well. We currently support 20 binary tool chains. I have requests for an additional 32. That puts me at 52 tool chains with a support organization of about one person. So we can't forget the impacts on small companies of making you developers' lives easier. I know. So yeah. There is the usability experience, as Christian was saying, support engineers, documentation engineers.
I'm not sure how much validation you're going to reduce by merging the backends.
It's not the validation, it's the customer support.
Well, I don't see the, I don't see the documentation efforts reducing. You're going to have to document more command line options, and more combinations need to work properly in that one tool chain that you produce.
Documentation is cheaper than support calls.
Nobody reads documentation.
No, yeah,
at least the support call can be read the manual, close.
Would more effort on having people's tool chains in their distributions make your life easier? So you're not supporting everything directly.
That's not the use case for my tool chains. That's the use case for Matthias's tool chains. Mine have different use cases.
Okay, so we are past halftime in our session, so let's recap on what are use cases, and then we spend the rest of the session talking about what are possible solutions.
I just want to add one more thing.
Yeah, we missed something. It's also the cost of maintenance of two compilers. If there is no, the cost of the maintenance of two different compilers in terms of if the machine description files are not, let's say, merged and communalized.
Right. So
I'd like to take that.
All right, Golin.
In terms of the machine descriptions for AR32 and AR64, whatever can be shared is already being shared. This is in terms of scheduler descriptions and so on. Beyond that, if you start putting in machine descriptions from one compiler into another, you're going to have a significant impact in terms of compile times. You are going to increase the number of permutations of options that you need to test with every single change.
Right.
And you are going to have to make sure that all the variants are tested properly for that particular thing. So if you look at that, for AR64, we currently have LE, BE, ILP32 is coming, so that's 4 ABI variants, plus architecture levels. And to that, if you add the AR32 toolchain, you've got float ABI soft, float ABI soft FP, float ABI hard, MFPU equal to VFPV3, and I can keep listing the number of options that you have to test for every single change, and it will actually make maintenance much harder.
Those machine description files are long as they are. Trying to go in there and edit and maintain them. As a maintainer, I would not want to have to work on that. I mean, sometimes when you're in there just working on one pattern, you realize you have to change others, and now if you have 64 and 32 in one file, I wouldn't want to work on that.
So you accept to make two changes when you have a, I don't know, it might not happen very often, but if you have a bug in one instrument, not it's very rare. Okay.
It is quite rare. The only point of time when we had some amount of similar shape of what happened was when we added the atomic instructions for AR32 and AR64 for V8A. V8A supports both AR32 and AR64. I think there is an educational exercise needed to remind people that AR32 also has V8A extensions. So when people say V8, it does not mean that it is AR64 only. There are AR32 extensions. And if we start moving the user base from the traditional ARM Linux GNU ABI HF triplets or whatever we have, to the AR64 compilers with command line options, we're only going to cause more confusion. We're only going to cause more confusion in the user space. And then because GCC cannot share the backends, we are then going to have changes in two places, and we are going to have to maintain the two changes in those two compilers. So it adds a lot to it will add a lot to the maintenance burden.
Okay, this is clear.
Okay, I think I have something of a unique perspective since I've worked on GCC, LLVM, and the Wind River DApp compiler. And the Wind River DApp compiler takes a very different approach from the other two. And in that compiler, there were domain-specific languages for handling lots of the sort of areas where there were lots of variants. One area in particular is we had customers who just wanted to put in, this is embedded, just wanted to put in the chip number that they were using. And then from that, we had ways of deriving, okay, well that's that instruction set, that set of libraries. And so our description files were very short. But we didn't build we didn't build one monolithic compiler. There was one compiler per ISA, effectively. And then within that, we would support variants. So it was sort of a hybrid approach, halfway between, in some sense, between what GCC does, where it's like, there's just one specific for every sort of variant, or the LLVM approach, where you link in everything you might possibly need, into one static thing. So there are ways of managing complexity that you might be able to use that sort of approach, but having, and this led into, even in the code generation, we had a domain-specific language for code gen, and there would literally be places where it's like, it was a tree matcher, there would be places where it'd be, oh, if we are a Coldfire version 9 or whatever, it's been too long, don't do this path or do this path. Now, I'm not necessarily advocating for that. That's part of the design space that we can look at.
So LLVM is going that way, that there are a few projects that are trying to get description files. They just say, look, I have this type of hardware, and you detect everything and automatically do anything you want. But instead of saying, oh, if this is core B of version 7, it actually says, does he have that feature? And if he does, don't take that path. And then we have a target description that says, this core specific has that feature. Right? So we moved from specific core identification to feature identification in the code gen, in the generic code gen. So you can use the description. So you can even build a new, in this project that they're doing, you can even build a new CPU that doesn't exist by pick and choosing features, and then you say, oh, my CPU does...
Some kind of table gen file?
Yeah. So, but no, even if it's not a table, the idea is to remove this from the table gen, because you don't want to add your proprietary core or secret core into a table gen file, and you can do this like in a configuration file, and you can mix and match and take things out and put things back. So the whole thing is there.
Yeah, the DF had that, a decade ago.
Yeah.
So, that was.
That's an old idea. It's just that GCC never
basically
followed.
you would go from a chip number to a sort of a generic, and then it would find out.
Is it a problem for ARM GCC compiler not to be at the same level as Intel compilers in terms of supporting 64-bit architecture?
Sorry, usability to that.
Yeah, on Intel you have a single compiler.
The book you said no earlier is the book Intel's on having more compilers.
Yeah. Mistake. Is it an issue or not? I'm done.
I mean, that solves a case of 3264 on that particular architecture, and there's a special option for doing that. And people have got very used to that over 15 years, but I don't think it's something we should repeat, and because we've got a different set of options, and so Spark and so's MIPS, and you just end up, it makes life very difficult for build systems and developers, because depending on what you're building for, you now need a whole different set of options, depending which set of random things your compiler uses, right? So it's very important. However, it's arranged under the hood in terms of what set of multi-libs is built together and installed together. You should use triplet-style ABI definitions to call your tools, and that way you know what you're getting. And in general, I'm in favor of building those separately, so you have one simple thing for each ABI, which will support several ISA variants and VFP variants in our case, under the hood. But yeah, and if build tools don't understand how to use multiple compilers, they need to be fixed. Trying to solve it in the compiler on a per architecture island basis is wrong, in my opinion.
So if we move to the sort of the fixing, I think. So yes, I am sympathetic. I can see why people want one compiler. I can also see why people want multiple compilers. And so, to me, the idea of merging the backends, just having looked at the ARM backend already, which is a complete mess because it's 3 backends in one, because effectively thumb 1, thumb 2, and ARM are all separate backends that we're selecting. Doing any form of merge between 64-bit code and 32-bit code gen in that GCC is just, it's just not going to fly from a maintenance or, but yes, we have to sell.
The other technical point you should remember is in the ARM backend, even though we've got 3 backends, these 3 instruction streams, ARM thumb1 and thumb2, can effectively exist in the same binary.
Yeah.
That's not the case with 64 plus 32. The instruction sets are not similar enough that you're going to reuse code in any way. You're essentially just going to create a union of the two backends. And, it's just adding complexity for the sake of it.
But so where I was going, so I'm meandering towards a statement that I think if we want to progress this, I think from everything I've heard, the way to do it is to actually go and do it properly, for want of a better term, and actually fix the target macros in GCC. So it's not merging backends, it's making the target macros work in GCC, which is great because it pleases your use cases that people feel they want one compiler, so they can build one compiler and they just select targets on the command line. It pleases Wookie's use case because you can still build all your target macros, and it probably really pleases the GCC community upstream because a project's finished that has been languishing for, well, ever since I started working on GCC 4 or 5 years ago, if not longer.
And the other argument is that I have one machine, V8. I'd like to have one compiler for this machine.
So having this would solve that issue for you.
Yeah.
That I'm aware. You see, I think the problem is worse than even you think in this case, because I know of people who want a compiler. They want one tool chain, so one compiler that can target ARM, that has all the libraries and everything built to target ARM 9 for a project, Cortex A9 for a project, Cortex A15 for a project, Cortex A53, and Cortex A57, because they've got one product line that they're still developing that uses each of those cores for different levels of the product line, that they want to just have one environment to build in. So it's not just, the actual problem isn't just ARM v8. There's some people, I think it's all the way up the street.
This is where 64-bit appears. Before ARM v8, there is no 64-bit. So the articulation point is there.
Yeah. So I think the articulation points there is much more obvious with the 32-bit to 64-bit change, but I think it's also there with earlier ARM architectures as well.
As well as the API.
And the API variants that we've gone through over history. So I think that there is a good argument, and actually I think, yes, we've had a discussion that actually if we went in GCC and sorted out the target macro structures, we could possibly, I'm not sure how practical it is pie in the sky thinking, just pull the Thumb1 backend out of the ARM backends that exist today and bung it to its own backend.
Yes.
And that probably makes maintenance and everyone's life. So
this is acceptable.
Yeah, right? And actually, so the option isn't to merge backends, it's to disaggregate backends.
Yeah.
But get the driver to use the target
Yeah,
macro.
we have the answer from the maintainers. It's not any cost saving. We merge the compilers.
So,
that's what I'm saying. It's not a cost saving.
But disaggregating them might be, and here's a way to do it that might help. Sorry. No, Maxim. I talked too much.
I just
yeah, I mean, there may be other technical issues with removing the Thumb1 backend, but we'll deal with that problem separately. At the minute, with respect to the specific problem of the two backends, ARM and AR64, I think they should continue to remain separate, and we should solve it properly.
So would it be fair to say that an ideal solution for everyone would be to first finish the GCC target macro / localization / modularization project, then split out Thumb1 into its own?
That's a separate project.
Yeah, so that's one project. Finish that project, then this will solve the problem of having ARC64 backend and ARC32 backend in one compiler, and then to further reduce maintenance overhead for ARC32 backend, because we now have a multi-target compiler, we can easily split the ARM Thumb1 backend into its own, and still the user experience will not change.
Yes.
Only the underlying compiler will change.
Yeah.
So this really is an advantage, is that we're not changing US.
Yeah, so I just want to answer.
And for the projects,
Yeah, so
for the you want to address the open
yeah,
independent?
yeah. So to answer Wookie's not question, you said it's a nightmare. Why anyone think of that, right? To try to merge things and make these things. So that was a quick solution for an ugly problem. We're trying to compile Android back in Hong Kong last year with Clang, and Clang understands many of the GCC command line options, but not all of them, and some of them behave slightly different. So Battle created a program that would just read all the GCC options and say, oh yeah, Clang doesn't like that one, oh yeah, that one actually means something else, and then he managed to compile Android. It didn't work, of course, he just compiled. But the idea was, shall we do a driver like this to be able to use Clang in the Android project, to choose, oh, I want to compile with Clang, but I know that only projects A, B, and C compile with Clang, the others don't. So the driver will know somehow, oh, I want a Clang for this one, I want a GCC for that one, and it would know then the options that the makefile is passing to the driver. If the backend is either Clang or GCC or RCC4 GCC or R32 GCC, whatever, it would know how to do all this, right? And I believe it's the same problem you guys have.
We have exactly the same problem, but it's a little bit worse than that. The problem is a lot of it not only depends on the functionality that you're talking about, but so not only does it not only what you're talking about the issue, the other problem is and the reason why Barrow started that way is because part of the Android build actually depends on not something that looks like GCC, but GCC.
Yeah.
So the exact functionality of GCC had to be there. Basically, it looked at strings that came out of various things, and the problem was that there were just too many places to to put it. So it wasn't a matter of working around problems. It was actually a matter of pretending to be GCC.
No, the binary name had to be GCC.
Yes, no, but beyond that, essentially the version output and everything else had to be identical as well in certain situations.
Not only the backend.
So no, it needs fixing. The problem was that Barrow was trying to basically get there as fast as possible.
Exactly. Yeah.
Right.
Yeah.
So this is not a solution.
No.
This was a hack to get it to see whether it would work.
Yes.
The point is that unfortunately that was the problem. Now he is working on fixing those other bits, but the problem is that Android is such
a mess.
The build system is terrible, and to work around it, the only way he could do it is by essentially putting sheep's clothing over top of it.
So most of those things are gone by now.
This is over the last year. So
right.
Oh yeah, there was.
Oh no, a lot of it's
beginning
gone.
of last
Absolutely.
year.
Yeah. So I mean, so most of the GCC-centric stuff is gone. There's obviously stuff that still requires GCC, but there's a flag now in AOSP to actually enable a Clang-based build. It's not completely functional yet, but there are people working on it, and the goal is to have a build bot up that actually builds, 99% of the tree with Clang, and then the 1% with GCC that's required there, as opposed to today where it's like some 5% of the tree is Clang and 95% of the tree is GCC. There is no 100% one way or the other plan for the very near term, because we just can't do it.
Makes sense.
So some things are Clang specific, some things are GCC only, and will always be that way. But the way that we've handled this is with this flag, and so the flag actually switches what compiler you're using and strips the flags and whatnot. So right now, instead of as a separate driver, it's actually the make files themselves are doing the heavy lifting of, oh my God, here's all the flags that I've been passed. What do I have to do? Would it be better to have something separate? Probably, because make files are awful to read and hard to maintain. But like we have something that
somebody has to maintain the other stuff. So there's another. So even though make files are hard to maintain, this other thing is also hard to maintain because you still have to mix and match and figure out which one. So the question is, where does the line go? Does the line come from the tool chains always have to support the same options? Or does the product that you're compiling is where it's supposed to be done. I say the product because
I agree.
Because then otherwise it's like, you know, there's a lot of collaboration that has to be done between the two compilers, and as we know before, that's not going to happen exactly.
Well, it's not just that, it's also being feature for feature and bug for bug compatible.
Exactly. That's
across division, across different versions and across different vendor releases, and you know, LLVMs used in so many places and so many different ways. The command line options are going to get inherited as they go into the various products. How do we ensure that all those products and the different versions of GCC align and make our...
No, it's impossible.
It's impossible. It's a nightmare.
No, that's not going to happen.
Design the options so that you're actually describing what it is you want. If your makefiles describe what it is you are actually trying to do in a sensible way, that's all reasonably orthogonal and not too architecture specific and so on, then that actually makes life simpler overall. That's what we should be trying to head.
That was the idea of the driver. Was this, so when we did that hack, we thought, oh, that's a horrible hack. However, you stop and think, look, there's so many options. What if we could get all these options and put into a common representation and then output all these options into the different architectures? The problem is this is like yet another compiler that will need another big team of hundreds of people just understanding all the options of all the variations of all the architectures.
Of both sides.
Of all sides, not both sides, all compilers.
Yes.
It's just like a waste of time.
Yeah, totally agree.
Good.
Okay.
Can we summarize the proposed solutions to the two major problems and then wrap it up?
Yeah. He summarized the GCC already.
Yes. So the proposed solution to the open embedded problem is to help Camraj to fix open embedded and make sure that the way he implements it enables the 64-bit and 32-bit ARM compilers.
And maybe more.
And maybe more.
Yeah. 128 bits.
Who knows what?
Yes. For
the Android is the same solution as just fix the Android build system?
Yes, and for the beautiful future, for our kids, we need to finish the GC modularization project so that they can have all the targets that they want in one compiler.
The approach